In this tutorial, I am going to show you how you can perform hybrid assembly using the tool Unicycler. Hybrid assembly is the use of sequence data from different sequencing platforms to perform genome assembly. That's the basic definition. So in this tutorial, what we are going to do is to first download the example data, and then we are going to install Unicycler, and then we are going to perform the genome assembly. So if you want to follow this tutorial, then you need to make sure you have a Unicycler operating system, i.e. Linux or MacOS. And you should also have anaconda installed. I have tutorials that show how to install anaconda on a Linux and MacOS system, so make sure you watch those tutorials. The links to those videos are in the description box. So once you are done with that, then you can proceed with the exercise. So let's get started. This video was made using this Galaxy tutorial. This is the page, and I will leave the link to this page in the description box. So that's what we are going to do. So if you want to read more about Unicycler, then you can also go to the GitHub page, which is here. I'll leave the link to this page. So here you have notes about the tool and then how to use it. So just make sure you come to this page and read more about this tool. Now let's get back to our tutorial. So we are back to the Galaxy platform. So what we are going to do first is to download the example data that we will use. So if you're on this page, just scroll down. You can come to this section, load data and access query. So you can click it and then you'll be sent to the section which has the links to the files that we are going to use. So we are going to use these files. So this is the illumina, and then this is the nanopore. Okay, so these are paired end reads, and we also have this one which is single end. So we are going to download these files first. So if you want to download, you can just highlight any of the links and then just click it. I'll right click and then just open it in another tab, and then I'll be asked to save this file. So I can do it this way, but I have 3 files. So instead of manually highlighting and then clicking to download them one by one, I'm going to write a bash script and then use that to download the file. So I'll show you how to do that. So first of all, let's copy all the links. I'll just copy them and then I'll move to the terminal to download them. So join me on the terminal. So on the terminal, I'll first create a working directory. So I'll say make the assembly, and then I'll cd into it. Perfect. So now I am going to create a bash script to download the file. So I'll say nano, then I'll say download data.sh, and then I'll open it. You can use any text editor to do that. You can use VI, Vim, or any text editor, but I choose to use nano. So I'll open this script. Once I am here, I am going to do this. I am going to add my shebang line, and then I'll move down. I'll then paste the links. These are the links. Because I'm going to download on the terminal, I'll need to specify the tool I'm going to use, and that is wget. So for each of these lines, I'll start with wget. Okay, so that's what I'm going to do. So each of them. And these are 3 files. Okay, there are 3 files here, so that's why I choose to add wget to each of the lines. Okay, but if you have hundreds of files or thousands of files to download, then there are better ways to automate the process. If you have such an issue, or if you have maybe lots of files you want to download, you can contact me and then we can arrange something and then work it out. Okay, so let's proceed. So I have issued the commands here. So I'm going to save the changes. I'll exit and then save the changes. Perfect, that's done. So I can do an ls, and I'm going to find the scripts there. Okay, so I'm now going to execute it. So to execute, you can say bash and then specify the file like this. Or you can also do this. You can add execution rights chmod +x like this, and then specify the file. And then you can just do this // and specify the file. So this will also download the files for you. So I'm using this approach. So let's download the files. Perfect. So the bash script is working, so we can see that the files are being downloaded. Currently, the illumina underscore f.fq is being downloaded. So let's wait for all of them to get downloaded. Okay, the files have been downloaded, so let's check them out. So let's do an ls, and we are going to see the files there. So I have my illumina reads, and I also have my nanopore reads. Okay, we are now going to install Unicycler. So we are going to use conda to do this. Okay, so make sure you have installed anaconda. So if you have installed anaconda, then what you have to do next is to add conda channels. We are going to add one channel, and that is bioconda. So I'll say conda config add channels, and I'll say bioconda. The channel has been added, so now I'm going to create an environment and install Unicycler in it. So I'll say conda create -n, and I'll say assembly, and I'll say Unicycler, and then I'm going to install it. So let's execute this command. Okay, I am now going to type Y to confirm. So once I do that, conda will download all the necessary packages, install, and then configure them for us. So let's wait for conda to finish its work. Okay, conda has completed its work. So if you want to use Unicycler, you have to activate the environment. The environment is called assembly. So this is the command to activate the environment. If you want to deactivate, you can use this one. So let's activate the environment. Okay, we are now going to activate our environment. So I'll say conda activate assembly. Okay, we have activated an environment. So now we can call Unicycler. Let's do an ls and check our files. What we are going to do next is to perform the hybrid assembly using Unicycler. I have my files here. These are the files. Okay, so these two are illumina reads. These are paired end reads, and we also have our long reads, which is this one here. It's a nanopore data. So with the long reads, we have the forward and the reverse. Some files will use R1 instead of F, and then R2 instead of R. So take note of that. Please know that if you have Pascal files and you want to perform genome assembly, or let's say if you have sequence data and you want to perform genome assembly, it's important to perform quality control. Okay. In the original tutorial, they perform quality control, but I am not going to perform quality control. The focus of this tutorial is to show you how to perform hybrid assembly Unicycler. So that is what I'm going to do. So the instructions for Unicycler can be found here. We have to specify our paired end reads, and we also have to specify our long reads. So let's go back to the terminal and then proceed with the activity. Okay, we are back. So we are now going to perform the hybrid assembly using Unicycler. So what you should note is that Unicycler also does polishing. Okay, it uses pilon. So we need to change the Java memory options before we can proceed. So first of all, I'll check where pilon is located. So I'll say which pilon. So I have that here. So I'm going to edit this and then change the Java memory option. So I'll say nano, and then I'll specify everything. So I am going to open it now, but you can use any text editor. I'm using nano, but you can use Vim or any text editor. So take note of that. Now let's open this file and then edit it. Okay, we have opened the file. So let's scroll down to this line here. Default underscore JVM underscore mem underscore OPTS. So we are going to change the first one here to 2G. That's 2 gig. So I'll clear 512M and then I'll say 2G. And then here I will change it to 6G. Okay, so we can save changes and then exit this editor. So let's do that now. Perfect, we have done that. So now we can run Unicycler. So to run Unicycler, you say Unicycler, and then you say -1, and you specify the forward reads, which in this case is illumina. Illumina underscore f.fq. Let's specify the reverse, that is -2. That will be illumina underscore r.fq. And then let's specify the long reads, that will be -l. And I will say minion underscore 2d.fq. Now let's specify -t for number of threads. We'll use 8. So here you can increase it. Okay. The genome assembly process is computationally expensive, so we usually recommend that you use a high-end PC, or better still, use an HPC cluster. So if you have an HPC cluster, you can increase this number to whatever cores are available to you. Okay, so you can change it to 10, 20, 30, or whatever, but I'm using my normal laptop. That is why I'm leaving it at 8. Now let's also specify an output directory. So I'll say -o, I'll say Unicycler underscore results. So now we can run this command. Perfect. So Unicycler has started its work. So the assembly is going to be done, and then polishing will also be done. So let's wait for everything to be done. Okay, Unicycler has completed its work. This assembly took about 1.5 hours. So in case you are using the 8 threads, then it's going to take about 1.5 hours. Now let's take a look at the output files. So let's do an ls, and we are going to find a directory called unicycler underscore results. So this directory contains the output files. So let's ls into it. So you say ls unicycler underscore results, and we will find the files there. A description of each of these files can be found on the Unicycler GitHub page. So if you're on the page, just scroll down to the output file section. So just scroll down and then click this one, the output file. So click it, and then you'll be sent to the section which has information about the various files. So you can find them here. So that's what we have. Now with the data we used, it was an E. coli sequence data. Okay, so that means that we are dealing with a bacterial sequence. So if I deal with bacterial sequence, then after genome assembly, you can perform a number of activities. Okay, you can assess the assembly quality using tools like Quast. You can also perform genome annotation using tools like Proca, Rust, PGAP, etc. You can also visualize the results using tools like IGV and then Bandage. And you can also call variants using tools like Snippy. Now I've covered some tutorials on this activity that I have mentioned. Okay, so I will encourage you to check the description box. You'll find useful videos that will help you to perform these activities. I call these activities post genome assembly activities. So make sure to check the description box for those videos. You can also check the playlist which is being shown here, and you'll find some useful tutorials that will help you to analyze your bacterial genomes.